Alright, here's my NES emulator for Xbox. We're going to do a little bit of more ROM hacking today. And today we're going to do Legend of Zelda for NES. I want to explain in this segment something called save states. Save states are commonly found in emulators nowadays, where basically it saves a specific instant in time. Meaning, you can actually roll back time. And it works by saving all of the memory addresses and all the things your CPU is doing. So we'll go ahead and do a save state. And then, oh, gotta run away. Oh no, went the wrong way. Load state. And it'll always load that exact instant in time. So it's really good if you're getting your ass whipped at a certain point of the game, or if you want to go on hunt for memory addresses. Alright, so we're going to go ahead and save. And I'm going to see if I can get the memory address for the sword. Alright, so we'll do some preliminary, start search. Now the value has most likely increased, so continue search for greater than before. Okay, down to 76. Now we'll load state. Now that should have changed, so it should be less than before, because remember, we loaded before we had the sword, and the emulator itself is looking for changes. So it has changed. We forced it to change. So we're down to 35. We'll go in here again. I love that fast forward button. Okay, cheat codes, greater than before, 29. Load state, less than before. Okay, it's not going down fast enough, so we'll use a few different tactics. Okay, we'll do greater than. See, it's not going down fast enough, so what we'll do is we'll go around, change some of the graphics for the data, or the data for the graphics, whatever. So now it should be equal to before. Down to, what is that, 6? Yeah, we're down to 6. So we're going to go for broke. Add these to the list. So we're going to go to our cheat codes. Okay. We got 06D, 6E, 83, 618, 657, 6F6. I don't know. Well, actually, the only thing that looks like it's plausible is this 657 as a value of 1. Because if a value of 1 says we have the sword, a value of 0 means we don't have a sword. Okay, so it's value of 7, locked at this value. And goodbye sword. We have no sword. Huzzah, look at that. Alright, so we're going to go and edit this back to 1 to prove that this is, in fact, the address for the sword. And there's our sword. Okay, now let's see what these other ones do. Well, let's see. If 657 is the sword, a lot of games are actually sequential in their memory addresses. So it's safe to say that maybe 618 and 6F6 are also values of some sort. Maybe I might do something useful. Alright, so let's take this up to FF, see if the game crashes or not. Enable this? Nope, I don't notice a difference. Alright. So we'll go ahead and delete this one. And we'll enable that to on. We'll edit this, so instead of 28, we'll make it 30, because this could be our lives. You never know what this could be. Nope. No noticeable difference. Alright, so we'll go ahead and delete that one. And I'm going to go ahead and just delete the rest of these. Okay, so we know that address 657 is for the sword. Now, what is at 658? Like I said, a lot of the times the addresses are actually sequential. So let's see, what was that address? 657? So let's see, it's 658. Am I in the right position? 658 0001. All right. So address 658. Set it to value of 1, lock it in place, go back to our game. Hey, look at that. We have bombs. So my assumption was right, that the game actually does use sequential addressing for all of your weapons. All right, so what happens if we set a value 659? Hey, look at that. We've got arrows now. Interesting. Interesting. What happens if we use this cheat code 65A, because that is the next value. Now we have the bow and arrow. Interesting. So it's safe to assume that you can go through a whole list of all of these addresses and find out what addresses go where. And we actually figured out that by using save states, we figured out sooner than later, because once you have the sword, you have the sword. There's no getting rid of it. Using the save states and the load state, we were able to force the game to load a previous instance in time where the memory values have actually indeed changed. So one more thing that I want to point out is some games actually use a higher value for different weapons. So the address is the same, but the value is different. Now, I've already done a bit of poking around and lobotomizing to Legend of Zelda. So I know in this game that the sword is, in fact, memory address 657. And I also know what happens when you set it to value 2. And now I'm showing you. Look at that. We now have the next level sword. And if you set it to... Oh, sorry, wrong button. If you set it to memory value 3, you'll actually get the Master Sword. There you go. Now you got the Master Sword. So some of the memory addresses, like for your potions and for your boomerang, are actually, if you can't find, like example, there's a blue and a red ring. The blue and the red ring might actually indeed have the same memory address, just have a different value. Here we are back in front of my NES emulator for Xbox, and we're going to do a little bit of poking around in Mega Man 2, one of my all-time favorite games to play and to poke around. So we're going to start a normal game. I'm going to zip through this. I'll paraphrase just in case this is the first time you're seeing any kind of NES hacking or lobotomizing, so I don't want to get into too much detail. I can use my handy-dandy fast-forward button to get through all of the long waits. The first thing we're going to do is our health. We're going to go to our emulator and we're going to start a search for what they would consider cheat code. Basically, we're using the cheat code system in this emulator, and we're going to get hurt. Now, as you noticed, the health went down, so we're going to search for values less than before. Got 100 values left, and we're going to get hurt again. Okay, so apparently it's less than before. We're down to 25. And got hurt again. Cheat codes. Less than before, we're down to 12. It's slow and painstaking, but we're slowly getting there. Less than before. So there's only 5 values that have been less than the previous. And one more time, just for good measures. Less than before. We're down to 2. I don't want to push our luck, so we'll add these to the list. We have 2 values, 24B and 6C0. Now, 24B is at a very high value at 164, which is decimal 164, and 6C0 is at value 12. I'm putting my money on address 6C0 because it's very low, and so is our health. So we'll go back to the game, and notice, however, whenever I get hit, because the emulator is basically telling the memory address to lock this at decimal 12, no matter how much I get hit, my lives, or my energy is not going to go down. But you know what? Constantly getting hit is really getting on my nerves. So we're going to go ahead and delete this 24B because it doesn't do squat for us. And we're going to start search for a new cheat code, or a new memory address, per se. We're going to get hit. Now we got to be quick on the button. Continue, start search. Continue, less than before. Cheat codes. Less than before. Cheat codes, less than before. What I'm trying to look for right now is the timer address for whenever you get hit. It makes you flash for a little while, making you invulnerable to attacks for a little bit amount of time. So we're going to go and add the 4 values. I don't want to push our luck to the list. So you know what? Let's enter a description, and this is health points, HP. Now let's see. It starts at 6C0. And there's nothing close into that range. Now, if you've watched the Legend of Zelda lobotomizing, hacking, whatever you want to call it, I explain that certain addresses in certain games are in sequential order. Now, I know this game very well. I'm not going to let too many secrets out. But 4B looks like it's kind of low in memory, But in fact, it could actually be the address we're looking for. I mean, it's at 36. It's one of the lower values here. I mean, 34 for FE, it could be it. We'll go for that one. Does it work? Nope, we just got hit, so that's not it. Oh, crap. Wrong button. I go a little too fast. Alright, so value 91, I wouldn't count on it. 4BF, I wouldn't count on it. 4B, I'm going to put my money on that one. Hey, look, now we're flashing. Come on, you bastards. Take your best shot. Kick your ass. Oh, but look at that. Notice that when we get some energy, it tries to add onto the actual energy bar, and it can't. So, let's raise this a little bit and try to get the full amount of energy. Now, we know that this is the invincibility, or as what I'd like to call it. So we'll enter description. I don't have my keyboard hooked up, so it takes me a while. I'm not going to sit here and hunt and peck descriptions for you. So now we know 4B is invincibility, and we know that 6C0 is our health. So with these two codes, now let's see if we can actually go and figure out if this is the maximum amount of health we can get. We need to get an energy capsule. Of course, no one is giving me one at this point. You son of a bitch. Come on, sometime today. Okay, apparently 1B, or value 27, isn't the maximum value of health. So we'll try 28. That looks about right. Yep. So decimal number 27 is the maximum value for health. Now, I'm just going to go and, skip over to a little bit later in searching. I actually have to play through the game a little bit before we can get to any of the areas where values can be searched. So if you bear with me, we're going to go and just cut over to the next portion of this. Alright, it took me about 2.5 minutes. Finally got to the boss. We're going to zip through this real quick, and we're going to look for the memory address for the boss's health. So, go to our cheat codes, do the standard thing, start search, give him a little damage, less than before. Cheat codes, less than before. Cheat codes, less than before. Cheat codes, less than before. Okay, we only got one code left. Now look at this. It's value 6C1. This is 6C0. Now, like I said earlier, that some of the games actually have sequential memory addresses. So, we've already narrowed it down. This is his health. And we've also proven that this game does use sequential memory addresses. Now, here's the problem. If we lock this to this value, we're not going to be able to defeat him. We can keep shooting. We can keep shooting. And we can keep on shooting even more. His health is not going to go down at all. So we're going to go to our cheat codes. Edit this to 0, 0. He has no health. But again, it's still locked at 0. So as soon as you hit it, it refreshes the value, and then boom, he's dead. Okay, I'm going to go ahead and fast forward this. So that way we can get to... I don't want the password. I'm just trying to hurry this up as fast as possible. I know you guys really hate sitting here just watching all this pointless crap. Alright, we're in the next stage, and we're going to start our search for cheat code. And what we're going to do is we're going to go ahead and we're going to look for weapon energy. So, alright, less than before, less than before, less than before. We got 5 left. I'm willing to go for one more. Alright, so, let's edit this. Well, not the description. Boss HP, BOSS, space, HP. Sorry people, bear with me. And this is the most likely going to be the Leaf Man weapon, or W as they call it. Retardation of the way they did this. Anyway, So we know that your HP, or your energy, has a maximum value of 28. And since it is right alongside our energy, the weapon energy is right alongside the health of your character, well, I think it's safe to say that this maximum value is going to be 28, or 1C. We'll enter description, just W. I'm lazy. There we go. Now we have the infinite woodman thing. Oh wait, here, look, here's an energy tank. Alright, so we're going to use some save state tactics. Alright, so we're going to save state. Cheat codes. Start search for cheat code. And we're going to go grab this. Now, well, here. Now our energy tank has increased by 1. So, and I just used it like an ass. Whoops. Load state. Hey, look, there's the energy tank again. I already explained save states and all that, so whatever. Grab our tank. Greater than before. We're going to load state. Now it's less than before because we went to a previous point in time. So, less than before. Okay, now it should be greater than before. And it should be equal to before, so continue equal to before. Okay, now it should be less than before because we loaded the save state. It should still be equal to before. See, and by throwing in these variations of greater than, less than, equal, not equal, then, you know, it really does make the search a little bit quicker. So, alright, so now it's got to be greater than before. Okay, we've got 10 codes to the list. Alright. Do any of these codes to you look like it could be the possible value? Well, let's see. Well, we have one energy tank. Currently. Well, we should have one energy tank, right? Yes. According to this right here, we have one energy tank. So we'll go to our cheat codes, and we will play with the ones that have a value of 1. So we have 1 F9 and 4, 5, F. Now, let's take a look at the memory codes that we already know. 4B, 6C1, and 9E. So, I don't know. Let's try this 4-5F. We're going to enable this to 2. There we go. It didn't change, so either I didn't enable the code. Nope, I enabled it. It's not this one. Let's try this one. 1F9. Edit our code to 2. Enable it. That's not it. And I just used it like a dick. Damn it. Alright. Go to our cheat codes. List cheat codes. So it's not this one. Delete code. Alright, what about this 13F? Make this number 1. Nope, that's not it either. A7. Well, 4B is kind of low in memory. So is 9E. Could it actually be A7, E2, E3? I don't know. Well, let's try this one. Let me get rid of this one first before it starts causing any problems. Whoops. Let's see, A7. Edit to 1. Hey, look, there it is. There you go. So it turns out that it was actually lower in memory, that, you know, we couldn't actually anticipate where it was. We had to do a lot of guesswork. And especially because we had a lot of these oddball addresses that only God knows where they're coming from. So we'll delete this one, do a little housework, clean up our code list before we get too confused. Bear with me. Alright, and we know that this is the energy tanks. So we'll just do T, A, and K. Alright, so, if we edit this, let's say the maximum value is 1C. Wonder what happens. Oh well, graphic anomaly. We've got a lot of energy tanks. Look at that. Alright, so we'll go to our cheat codes and we'll stop dicking around with the game, making it unhappy. We'll set it to, I don't know, 5. 5 is a nice number. Still more than what we need, but I have to admit that's mighty dick waving rides having all them energy tanks, especially when you have infinite energy and infinite woodman energy. Okay, so I'm going to go and play the game a little bit, go further into the game, and we'll continue from there. we're finally at the boss now. We're gonna see if the memory address that we have for boss energy matches this boss. So let's watch what happens. Well, that's unexpected now, isn't it? Apparently the programming states inside the game itself that the boss has to stay there until his health reaches a maximum value. So if we lock the boss's HP to 0, it's never going to continue. It's never going to move on from this point. So we have to disable this code to allow his memory to go up. So we know that the boss's HP is in fact universal through the entire game. So we'll just go back. Now, with this emulator, I can actually change this code to something called an if-then statement. I'm not going to go through it because not all emulators support it, and I really just read the README file to your emulator. But basically, I can make two codes. The first code would say, when this memory address is equal to decimal value 28, then go to the next code. And then the next code would say that the memory address C61 is equal to 0, or set it to 0. So we're just going to re-enable this. Do it the easy way. Kick his ass. Do a little bit of fast forwarding. I know you guys hate to wait. Okay, and we'll go to the next stage. So is it safe to assume that since the boss energy is the same, the address for the weapon energy is the same? I don't know. Let's find out. We'll get the game loaded up. We'll go to our Metal Man weapon. We'll start our search. Use a little bit of the weapon and do our usual routine. Wow, down to 3 values already. Okay, we've only got one possible. Alright, so it's A2. Well, knowing that the game is sequential, or assuming that the game is sequential because of the HP is 6C0, the boss's energy is 6C1, and that the memory tank is at A7, and the Metal Man is at A2. I'm going to enable this, and we're going to edit this to the possible maximum value, 1C. So, okay, so Woodman is at 9E, and the tanks are at A7, and the Metal Man is at A2. So somewhere between 9E and A7, there's a whole range of values that do only God knows what. And that would be the whole point of going around and exploring the rest of the values. Now, I'm not going to go ahead and bore you with me sitting here punching in all these memory values for like the next 10 minutes. So basically, all I really wanted to prove was that in a lot of games, the memory addresses are indeed sequential. And in fact, that even if they are sequential, that the actual value can also determine the strength of your weapon, like we saw with Legend of Zelda. Now what I'm going to do is I'm just going to go and pause it over here, and I'm going to go in and I'm going to punch in some more memory addresses that I'm going to assume that are for the other weapons and other things. You can go ahead on your emulator and do the same thing. You'll get the same results as me, but I don't know, at least you can say you tried it. I'm going to go ahead and spoil the fun for you guys. I'm going to show you two really key memory addresses that, you know, when I found them, they made me ecstatic because it just showed me that how the game was actually put together. Here's a memory address, okay? 009A. This is the memory value for what weapons you actually have. Right now, it's at value 1. And if we go into the game and you take a look, I've only got the Heatman weapon, okay? And if you noticed, I don't have infinite energy, so we're not gonna sit here and just keep firing the weapon, because we can use this code to find the rest of the weapons, or the memory address for how much energy you have left in a weapon. So we'll edit the code to say 2. Now we have Airman. That's all we have. We don't have Heatman and Airman. So memory value 1 is Heatman. Memory value 2 is Airman. So we're going to go to our cheat codes. we're going to go back to the memory address, and we're going to make it 3. Now look at that. It's Heatman and Airman. So, memory address 4, what would it be? Or value 4 for this memory address, what would it be? Woodman. Okay, so wouldn't you assume that memory address 4, 5, and 6 would add another one? Well, that would be incorrect, because you have to remember, you can play this game in any order of bosses that you want, in any order of stages. So there has to be an individual value for every combination of weapons. I hope you understand what that means. If you don't understand, I'll try to put some show notes about Boolean and how Boolean and logic will apply to this. So if you really are confused about this, go to the show notes. I'll try to explain on the show notes. So we'll go to the cheat codes. With what I know about Boolean and the way memory and logic works, right now the current value is 4. And if we set this to 5, it should be Heatman as well as Woodman, I believe. I could be wrong. Heatman and Woodman. But you have to remember that this is just the memory address just to enable the weapons. So if you really want to be a bastard, just go ahead and FF. You have every single weapon. But look at that. We have a small missing gap. Now, if you played the game, you understand you're supposed to have 3 special items that you gain after defeating certain bosses. And I'll spoil it for you a little bit. 9A, right? So we'll add a new code. Let's see, 009B, I believe it is 0001. There we go. This memory address 9B is in sequence to 9A. So 9A are what weapons you have. 9B are what items you have. And there's item 1. There's item 2. What happened? We're supposed to have item 3. No. According to Boolean algebra, we have items 1 and 2. Now we're going to go to the next memory value, value 4. This will give us item 3. There's item 3. We'll go to the next memory value. Can we guess what's going to happen? 1 and 3. Now what happens when we go to the next memory value? 2 and 3. And when we go to the next one, whoop, went a little too far, getting ahead of myself. Exciting stuff. When we go to memory value 7, keeping in mind this is an 8-bit system. That might mean something to you. I hope when I said that, something in your head clicked. If it didn't, screw you. 3. Something in your head should have clicked about it being an 8-bit system. Look, now we have items 1, 2, and 3 because of that memory address. Now let's see what happens when we go to the next value. Everything disappears because we just exceeded its maximum value. Huzzah. So we're going to go set this back to 7. Whoop. Forgot to save it. Pressed the wrong button. There we go. So now we have the memory addresses for all of the weapons. Now all you'd have to do is sit here through every single weapon and systematically, you'd have to systematically go through all of the memory addresses from 09C all the way up to 00A8 to get all of the energy. Actually, the energy is 009C all the way up to memory address 00A3. Those are the actual energy addresses. You go ahead and, if you want to, punch those in. I'll put all the links and whatnot and some good stuff on the show notes. And I'm really hoping to see an activity of people actually going into these NES ROMs and posting what you find. Let me know what you find, people. I'll post the stuff that I've found so far. And hopefully within the next installment of this segment, we'll get into something a little bit more impressive than just poking around your energy, poking around, your weapons and do something a little bit more interesting. So for now, I hope you guys enjoyed, and let me know what you think. Hit the show notes. Give me your opinions. I was asked to do some simple segments using what I know about electronics and show you guys some simple things you can build or repair. The first thing we're going to start out with in this segment is a hands-free headset. Now, I use Skype a lot, and I've also used my cell phone a lot, and quality hands-free headsets can get a little pricey, but to tell you the truth, they're really simple to make. You probably have all the parts laying around your house right now, and if you have enough interest, you can build one for damned near no cost. So, let's get started. Here we are at the work table, and some of the components that you'll need, the actual essentials, are pretty much just a headphone jack and a microphone. The headphone jack you can get from any bad pair of headphones that you have laying around. Your microphones can be obtained from either a telephone or from an old hands-free headset, computer mic that doesn't work. This one's out of a standard telephone. This is actually out of a hands-free headset for a cell phone. These are also inside cell phones themselves. So I'm going to go and hook this up to my little clamp here. I hope you guys can see it. This is the first time I'm using the lens. And if you really suck at soldering, it's obvious, don't use the small one. So we're going to put that one aside. The first thing you want to do when you get your microphone out of your project is, out of your whatever you're scrapping it from, is make sure your contacts are clean. These are relatively clean. I mean, I got a bit of excess solder on there, but meh, who cares? Your second step is to go get your headphone jack, and you're going to strip the wires like so. This actually uses lacquer-coated wire. It doesn't use that yummy rubber coating. So you're actually going to have to use a lighter or something, fire, and gently burn off that lacquer coating. That's why these things look kind of charred. There's no way to actually strip it off. Now, those are the essentials. Basically, what you do here is you tie together your ground, which are going to be two common colored wires. And then you tie together your left channel and your right channel. Left channel is usually white. Your right channel is usually red. So with that being said, I mean, this is uncommon. This uses red and green, but it's safe to say red is right channel, green is left channel. Tie them together because some computers and devices require actual stereo microphone jack. It's not very often, but hell, you've got a stereo, you might as well cross them, have 100% compatibility instead of 98.9. And then from here, you solder this onto your microphone. Now, if you notice over here, on this side, right here, there's actually a circuit bridge and some solder that attach the pin to the actual case of the connector. That's your signal ground. The other side is your positive, or so to speak. You can hook these microphones up backwards, so if it's not working, you have one of two problems. Your cable is bad, or your microphone is plugged in incorrectly. It's either that or you just have your headphone jack plugged into the wrong port, but I'm going to assume you're not that stupid. Once you have that soldered on, it's all about a matter of constructing your microphone stem, or what they call the boom. For that, you have to improvise. This is called a loop insulation connector. You can go and get a pack of these things from any like hardware improvement store. Automotive stores have them. Electronic shops have them. They're very common. And they're also very inexpensive. You're also going to need a heavy gauge wire. This is 14 or 16 gauge BX cable. This is the wire that runs in your walls for the power to your house. This is a solid strand copper wire. It's very, very rigid, very durable. You'll also need some kind of outer insulation from something. This is insulation from, or actually a chunk of power cord from a vacuum cleaner. We're not concerned about the wires on the inside. All we want is this nice, soft, flexible rubber outer sheathing on the outside. Basically, we're going to use this to hide all our shame, also known as the microphone stem. If you can't get your hands on vacuum cleaner cord, you can use an old USB cable, Cat 5 cable, or I'm pretty sure a lot of people actually have coax cable laying around the house. All you want to do is cut the appropriate length and pull out all the insides. When you're pulling out the insides, make sure your cable is straight as possible. You might have to actually massage it in one direction every once in a while to straighten out your cable. It should pull out no problems. You could also use solid copper wire for small microphone stems. This isn't the ideal. It's kind of flimsy in my opinion, but hey, if it works. And you can also use paper clips. Straighten them out. They don't have to be super straight, you just got to get the general idea. Really don't have to get into the tools that you'll need. I mean, common sense, pliers, needle nose, you know, wire stripper, soldering iron, blah, blah, blah. So what I've done was I actually took a length of the copper wire and ran it through the inside of the vacuum cleaner insulation, or your Cat 5, or your network, or whatever you got laying around the house. I made a loop out of the copper to hold in my microphone, and using my needle nose pliers kind of crimped it in place so it's relatively sturdy. I also ran the headphone cable through the inside of this and pretty much just soldered it straight to here. So if I plug this into my computer right now, you know, it'll work just fine, no problem. But what I did was I used the loop connector, and I threaded the copper wire in here, and you crimp it on either using a pair of needle nose pliers, standard pliers, or appropriate crimpers, and then now you just basically use a nut and bolt to attach this to a pair of headphones. Now, this is kind of big and beefy and bulky. This is actually going onto these. But not everyone wants to wear a pair of headphones that makes them look like they're going to land an aircraft. Maybe you want to do something a little bit on a smaller scale. So what I did was, same thing, just smaller scale. When you buy the loop insulation connectors, you have to make sure that you get the right size because they're actually for like specific gauge wires. This is just a paper clip that I straightened out, and I used a loop. Now if I can go ahead and find that little microphone that I always seem to lose. Yes, yet again, I've lost it. Anyway, really doesn't matter. Basically, I put the microphone in here, I crimp it on, I pull the insulation back a little bit, and I solder the wires on, no problem. And then I just attach this piece to a smaller set of headphones. Hunky-dory, fine and dandy. If you can't get your hands on the loop connectors, just go ahead and make a loop out of the actual copper wire if it's thick enough, or your paper clip. Usually they're sturdy enough where they'll work. You can also use heat shrink tubing. Heat shrink tubing is some good stuff. You basically put it over your wire, you apply a little heat, and the tube shrinks around whatever it's on. So you can also use that to insulate your wires, or basically just, you know, you can use this as your ground because it's made out of metal, it is a wire, and then just run one single thin wire along this using heat shrink tubing along the way to crimp it on. Now, let's say you really want a hands-free headset, but you don't care to have speakers built in. I actually took some BX cable and just made a wraparound microphone stem, which I will build off camera because really soldering microphones and wedging them in place isn't very entertaining to most. Same principle, you know, it's a nice sturdy wire. Shaped it to the size of my head, with a little small, so this actually springs onto my head. Microphone stem comes down around, and you know, microphone just gets placed in here. So I'm gonna go ahead off camera real quick, you know, piece all this together, and I'll give you a show of the final product. All right, took me about 5 more minutes. I finished up my headset, and the one I have on right now is just the 14 gauge solid copper wire, just as a microphone boom. I mean, it's really nothing too complicated. I use a little bit of heat shrink tubing on the sides to keep the cable on, and that's it. You know, if you actually want to have some foam for the microphone, if you scrapped a pair of headphones, you probably have some foam from the earbuds left over. Go ahead and use that. One thing I like about this one is if you don't want a headset mic, you know, just rework it. Now you got a desktop mic. Woohoo! The boom microphone over here, all I did was, you know, couldn't find a nut, so I just used a spike from my pile of spikes that I've got laying around. Here they are. That's it. To tell you the truth, I really do think the microphone stem should actually be cut off about here, but for something I slapped together in about 5 minutes, I really can't complain. Again, it would be a good idea to put some kind of soft foam padding around the microphone. That way you don't have explosive letters like P and B, which, you know, there's a lot of, like a puff of air whenever you speak. So, you know, if you have any questions, comments, or inquiries, hit IRC or hit the show notes. You know where we are. So, hope to see you then. Have fun and good luck.
A while ago, somebody sent me a link on Hackaday about reprogramming the LED display signs. It wasn't really much of a hack. They just basically took the original remote to the signs and were reprogramming them. We decided to take JP1 remotes, reprogram them, and use them to reprogram the
Yeah.
LED display
Yeah.
signs.
Yeah, pretty much. That's it. We were able to get our hands on an original remote control thanks to Mustang, and like you said, we reverse engineered the infrared protocol and we put it in this type of remote called JP1. A JP1 compatible remote. JP1 is a type of programming bus that was put in by a lot of the manufacturers, so they can actually like put in like remote control updates and patches and whatnot. The remote controls were commonly sold at Radio Shack, among
Kmart, Walmart.
yeah, a couple of places sell them, and basically we cloned these functions into here. It's just a matter of making a relatively easy cable. I mean, if you saw like how to make a controller interface into the printer port, you can make this. It's simple as fuck. Now it's just a matter of the software. We'll go over to you on the software side, and you'll explain exactly what JP1 is and how to use it.
Okay.
This is the home of JP1. All the information about where to download and what you need, including how to build the interface, is here. You'll need to hit their forums or Yahoo group to download the programs and other files you might need. Before we start, if you have an XP or NT system, you will most likely need to install the direct I/O drivers. The install is painless and straightforward. If you fuck something up here, you shouldn't be involved with wargramming. Please go to your local highway and play in heavy traffic. Here we have ir.exe running. We need to download the remote definition file or RDF pack and extract the file somewhere. Once you extract the file, set up the path leading to the files. Plug your interface in and make sure it works. It should respond correctly. If it doesn't, make sure you have the right kind of interface selected and your parallel port is set up properly. Once you have everything up and running, download the contents of your remote and back it up. The program should auto-detect what remote model you have and apply the correct RDF. Keymap Master is an Excel script that allows you to create device upgrades from learned signals or a list of EFCs and OBCs and import them as a fully supported device for the JP1 remote. This was the key in reverse engineering the BetaBrite IR protocol. You will need to enable macros for this to run. Once you have it up and running, you will need to select the remote type, device type, protocol, setup code, button code method, and main and sub device. If you program your remote and you can't load the setup code that you've created, you probably entered an invalid setup code. Check out our show notes for a list of OBCs and EFCs. OBC stands for onboard computer, and I think EFC stands for Extended Function Code, but I could be wrong. Either way, as long as you have the OBC or EFC command for the button you want to add in, you're good to go. Go into the functions and start to add in your OBCs and EFCs. What you are doing now is making an upgrade file for ir.exe. That tells the remote how to function in the same manner as the BetaBrite remote. The only thing you have a problem with is the BetaBrite remote has way many more functions than your remote. You'll most likely need to have 2 or 3 setup codes to complete the entire list of buttons. This part is where you have to get creative. Figure out how you want to have your remote mapped out. Go back to the main tab and notice that there is some hex code in the device upgrade box. Hit the copy button. It will ask you if you want to automatically import the device upgrade into ir.exe or not. For now, we will do it manually. Once you have the device upgrade copied, go to the Device tab and click the Add button. Paste in the hex code and click OK. You have just added this device into the JP1 remote. From here, you can just upload it and start pounding out sequences onto your remote. Or you can make life a little bit easier and start adding in macros. Macros are pretty much a script for your remote. You can tell it to turn on your TV, DVD player, surround sound, turn up the volume, dim the lights in your house, or play a movie all with the push of one button. Basically, with a macro, you tell the remote a list of things to do with a specific button being pressed. Go into the Macros tab and start fucking around. It really doesn't need much of an explanation. If you need help, hit the show notes or the JP1 forums and user guides. They have great tutorials.
As you can see, JP1 is fairly simple to use, just not everybody can get a hold of the remote.
Yeah, that's... eBay is kind of fruitless, Amazon pointless, Radio Shack worthless. I'm a hardware hacker, so basically what I want to do now is make this as easy as possible for everyone to get into. I don't want it to be exclusive. However, I don't want every, Sally sob story and, Harry Hacker going around being, I'm so neat, I'm so cool, I can go program signs with neat speak. Fuck you! Okay? The easy shit that I'm doing is coming out last, if I even release it at all. But the first thing I did was my infamous pink Game Boy Color. Many of China has feared this Game Boy. Reprogrammable cartridge, as well as the programmer. Good luck getting your hands on them. Good luck building them. I'm an experienced electronics guy. I can't build them. But basically, I've got my hands on it, so yay for me. The Game Boy Color has an infrared data port. Some very, very intelligent people created software to basically receive, edit, and transmit infrared signals. So with my hardware talents, I can actually romp around the city streets looking for signs, just go, meh, meh. And if someone says, what the fuck are you doing? I go, I'm playing Pokemon, asshole. Don't make my Raichu kick your ass. And, nah. And you know what? I also have a not pink Game Boy Color, so.
For the straight people out there.
Yeah, for the straight people out there. I've also got my Pocket PC. This was like the easiest damn thing in the world. Once you have the config file and the appropriate software, software is not free. I think there is free software. Matter of fact, you have a Samsung phone with infrared?
Yeah, I'm still trying to get that working.
Yeah, we might actually be able to figure out a way to go and use any Joe Schmo phone that has infrared. There's a free program you can put on your phone to transmit infrared. But anyway, you put the config file on here, which I'm not going to be releasing for a little while for two reasons. Laziness, and I don't want people abusing this. And you can just go there and pound out macros on your Pocket PC, or hell, the config file is not for a specific program. It's a universal config file for any program that can read a CCF file. If you're familiar with the Pronto remote control, they're like $200, $300 for the remote control. It's pretty much a PDA that controls your entire house through infrared. Even those would work. The simplest thing that I'm working on right now is MP3. And that's right, yes. I said MP3. In the long run, I mean, I've already got this working and verified. It's just I don't plan on releasing the how-to just yet. You can actually encode the infrared data into an audio format that can be spit out at high quality, as long as you have a high quality MP3 or CD audio, through a very small, simple electronic device which you can build from any Radio Shack parts to go and transmit the reprogram codes.
Could you use some of the higher end cell phones that play MP3s?
Maybe.
Can you play that back?
Maybe. I don't have one. Fucked if I care about cell phones. So
Yeah, everybody's got them now. So.
yeah. Well, hey, if someone wants to go and once I release the audio version, then yeah, it'll definitely be done. As a matter of fact, I've also worked on a piece of hardware where basically it's just a lens and an LED array and a power supply. So you can actually hook what I call an infrared rifle or an infrared blaster to your device, and hell, I've gone
What kind of distance could you get on that?
I've gone in excess of 150 feet. I mean, on a clear night with no sun, with enough LEDs, you can probably push at least 350 feet, at least.
It's a good distance.
Yeah. So, if you're really interested in this, check the show notes. We'll give links to the JP1. Later on, if people aren't abusing this too badly, I'll release the config file for the Pocket PC, and still, if it's not being abused, I really shouldn't say I should say we. I mean, this really was a group effort. Without Mustang, none of this could have happened. He was able to get his hands on a lot of the hardware, and he did just as much work as I did, so I can't say I apologize.
Yeah, no problem. I like behind the scenes work.
Yeah, he admits he sucks in front of a camera. But either way, as long as people don't abuse this, I'll release the easier and easier and easier versions, with the MP3 version absolutely last. If I see people abusing it, I'm not going to release it. I don't want a whole bunch of noobs reprogramming signs with profanity. Oh, as for law, ooh, I almost forgot that.
Yeah.
Yeah. I mean, we walked around all of Times Square, and how many signs did we find?
More than I can count. Not one that's programmable.
Not with our hardware, anyway.
Not yet.
Not yet.
Just need another boring winter.
Yeah, we need another boring winter to get some more work done. The law states that This can be, in New York State, this is a trickery device, so this is deception of a trickery device. If you reprogram the sign with slander or foul language, they can actually hit you with juvenile conduct ticket. You know what? I've actually gotten caught doing this. The guy came out of the store and said, "What the fuck are you doing?" And I said, "What does it look like I'm doing, stupid? I'm reprogramming your sign." But the only thing I was doing was just seeing if it was going to actually go. I wasn't going to like save all the settings. Really, if some guy comes out of his store, yells at you and threatens you that you're reprogramming his sign, tell him to fuck off and hit you. Because when I'm pretty sure the cops are going to come running real fucking quick. Because, yeah, I need you to come to my store right now. Some kid's reprogramming my sign.
Yeah.
They're really going to come running quick. Just don't be a dick. Really, don't be a dick. By the way, we're calling this wargramming. Did we mention that?
I don't know. Everybody's heard of war driving, war hopping,
War dialing.
yeah, war dying.
Yeah, I tried doing some war dying at one point. I don't have it on camera, sorry guys. But yeah, we decided to call it wargramming, as in reprogramming and sending a message, like a telegram. A gram meaning a form of text-based message or like written message. So wargramming for the masses. Enjoy, everyone.